That's it. That's the fucking start of the video. Hi, my name is Neff, and I am a musician and also a programmer. That last one is actually kind of for real. I do programming for a living. So I am a programmer and a musician. I have studied classical guitar for about 5 years, and then I obviously continue practicing my 40 hours a day every single day. I play the guitar, acoustic, classical, electrical guitar. I also play piano. I play the melodica. I play a bunch of instruments. I was trying to learn violin. I'm not. I am not good at the violin, but that doesn't mean I didn't try. I was also trying to learn the recorder. That went well. But there was always one instrument in particular that I found amazing. Like, I discovered this almost like fucking 6, 7 years ago. Holy shit, I'm old. And it was the theremin. It's a really, really weird instrument. You play that instrument, you play the fucking theremin by not touching it. You play the theremin by not touching it. So basically, the way a theremin works, it's just a bunch of antennas. I believe there are 2 antennas in the theremin, and you hold your hand towards the theremin, and the closer you are, the higher the pitch gets, because the theremin is basically like an incomplete circuit, and your hand acts as, like, I think, a capacitor. I didn't study electrical engineering. I almost failed my electronics class from last quarter, but the point is, the theremin is fucking cool, okay? You can watch people play that shit, and it just looks fucking amazing. And I want to look amazing as well, because isn't that what life is all about? So, naturally, I wanted a theremin. There's only one problem. I live in Mexico, and if you're unaware of the situation of Mexico, the economical situation of Mexico for the last, what do you want, fucking 50 years? It's been awful, okay? So here we are. I'm fucking broke, and I still want a fucking theremin, because it's fucking cool. So I thought, well, if I want a theremin so bad, and it's so fucking expensive, why don't I just build it myself? I'm a science guy. I can do that. I can build shit. But here's the problem. First, I thought, hey, I have 2 connects because I am one of the 10 people, I think, that bought the first connect, didn't think it was shit, and then proceeded to buy the second fucking connect. So then I said, hold on a second. There's a thing called Arduino, and if I remember correctly, Arduinos have sensors. So maybe one of these sensors would be able to detect the distance, between the Arduino and the object. And I looked it up in Google, and sure thing, there are Arduinos that can do that kind of stuff. It's specifically the ultrasonic sensor that you can just plug into your Arduino, and it will give you the distance. It's super easy to use. But here's the problem. I know shit about Arduinos, okay? All of the programming that I have done has been in software projects. So things like games, desktop applications, mobile applications, web development, all of that I'm pretty good at. But I have never done anything close to like hardware programming. My point still stands. I am just right now going to go get a fucking Arduino, and I'm going to try to make a theremin out of it. What could fucking go wrong, right? The fuck? This is the Arduino Uno, and it's what we're going to be using to connect the computer to the sensor that will measure the distance. And by the way, It's just as useful as it is fucking difficult to open. God fucking damn. I spent like no joke 3 minutes trying to open this shit. And then there's this little guy, which is the sensor. It's an ultrasonic sensor that will help us measure the actual distance. The way this works is it basically sends an ultrasonic wave to the object that's in front of it, and then calculates how long does it take for that wave to bounce off the object and travel back to the other speaker, and then it uses the speed of sound to calculate the distance. Pretty straightforward. Now, to connect these two systems, the Arduino and the sensor, we're gonna need some jumper cables. In fact, 80 fucking jumper cables because they didn't sell them separately. Hey, Neff from the future here, and I just finished the project, and I wanted to get a little nerdy on how this works because I think it's just super interesting. And, well, if you're here for how you would code this project, I think this would be a good way to describe it so you can code it yourself. So let's start from the basics. What do we want? We want to simulate the behavior of a theremin. That's pretty straightforward. My theremin works a little bit different though. The closer you get to the device, the lower the pitch gets, and the further away you are, the higher the pitch gets. It's a little bit different from a normal theremin, but it emulates the behavior in a really decent way. I like how it emulates the behavior. It's just a fun project, you know? The first thing that we need is obviously sound. So we need a way to get sound from the code that we wrote from this program in C# that I'm writing to the computer, right? I'm playing the sound on the speakers of my computer, so I need to get the sound from the program that we're coding. However, there's just one problem. Normally, when we're speaking about programming, we would need to get the sound from a file, maybe a .mp3 file or a .wav file. Those are the most common ways on which you would go about adding sounds to an application. You know, just pre-recorded files, which is a really good approach for some cases, but this will not work on our case because we do not want to play a file and then simply, you know, pitch shift it. We want to make the sound ourselves. So we need to ask a little bit of a deeper question, and that is, what is sound? Okay, so sound is just basically wiggly air, okay? It's just air molecules moving back and forth at a certain frequency. A frequency meaning how much of that cycle iteration happens in a second. So if you move one thing, like if you move one cycle 1 second, that's 1 hertz of frequency. That's the unit that we use to measure frequency. So one cycle over 1 second, that's 1 hertz. If you move 2 cycles in 1 second, that's 2 hertz. And the frequency is also what defines the note, the sound that you're hearing. So when I play, for example, an A, holy shit, this is difficult. That A note is about 440 hertz. So the air, or specifically the string of my guitar, is moving the air back and forth 440 times a second. That's what makes the musical note. So that's one part. Sound is wiggly air that has a frequency, but it also has an amplitude, okay? The amplitude is basically how loud the wave will be. The amplitude is literally how thick the wave will be. Okay, great. So we've got the core components of sound, which are frequency and amplitude. There's also wavelength, but we're not going to worry about that right now. What we need to do right now is to figure out a way to feed that information, that wavelength and that frequency, to our sound card on our computer so it can play it back on these speakers. And that's easier said than done, because the normal way that you would go reproducing sounds on a frequency based system on C# specifically is by using the console.beep method. Now, the console.beep method reproduces a beeping sound, which is generated, I think, using a sine wave, which is basically given by this equation right here. But that's not what we want, okay? Why not? Because it will just play back one sound like automatically for a certain amount of time, for a fixed amount of time. And we want this to go infinite. And also, the default function for the beeping sound on console.beep is does not take a frequency. There is also like an overload of that function that does take a frequency, but it also takes a duration. So what does this mean? This means that we cannot actually go ahead and just play back the sound that we want at a certain frequency that we want for an infinite amount of time, or for an unspecified amount of time, which is what we want. Otherwise, we would get this god-awful sound. And we do not want that. Now, how do we fix this? We basically create our own signal. We want to create a new wave that can be interpreted by our sound card as how much you would need to vibrate the membrane on the speaker to play a certain sound. And that's exactly what we're going to do. We're using a library called Audio to do that on C#. So we can, like that, just create a class called Signal, which is going to be extending another class. I believe it was Wave something. Wavestream, that's right. And within this class, we can actually write all the code for how to play the signal, how to play the wave that we want indefinitely, like forever and ever, right? I got most of the code from this tutorial right here, which I am going to try to link in the description if I remember that. Okay, so within this signal class that we now have a way to tell the computer to interpret the information of the signal object, the frequency and the amplitude of the signal, so you can, play it back on your speaker. However, there's just one slight problem, and that is that we want to create a sound based on a wave, a certain basic wave, right? We could just go ahead and create the standard sine wave, but you know what? It's pretty fucking boring just to have a sine wave. I mean, if you're gonna code the theremin by yourself, you better make it a little bit interesting, right? So I decided to also add the functionality for a sawtooth wave and a square wave. There's also a triangle wave right there, but I'm not sure if my equations are completely correct for that one. I guess they are because I got them off of Wikipedia, but be a little bit skeptical and please check all the equations. So the equations are defined in this bit of code right here. I hope I'm pointing to it correctly. I'm going to link to the Wikipedia articles for each and every single one of the waves, so you can see how they are formed in their mathematical sense and how we're translating that to the code. And so now we... Okay, fuck me then. Yeah, Kira. Who would have ever supposed that it was Grisabella the Glamour Cat? Grisabella the Glamour Cat. Now we need a way to figure out the frequency that we're gonna play based on the distance of our hand from the theremin to our hand. Because, we cannot actually use the real distance of our hand to the theremin, because it will sound something like this. Now, I know what you're probably thinking. This is just shit. There is absolutely no way that you can produce, music with that thing. And you're absolutely right. There is no way that we can produce some sort of pleasant music with that instrument right there, but that's because we need a function, a mathematical function. And then idiot me proceeded to try to develop his own formula to get the frequencies of the fucking scale. God damn it, am I stupid? Okay, so I spent like 4 hours trying to come up with a good function that could relate all of the frequencies of the notes with like the distance that we have with that fucking sensor, and I couldn't come up with anything. Okay, like, don't get me wrong, I was close. The thing is, I am not particularly good at math. However, I remembered that there's a fucking thing called Google, and you can literally Google this shit, and it's right there. So that, hold on, where is it? That is the function that we need to code in order to get our proper frequency. And this right here is the function translated to code. It's very, very simple. It's the same exact formula. I only like subtracted 2 here to tune it a little bit better. So we are going to get a different tone. If I just delete that, we're going to get 440 hertz, which is, again, A4 at the lowest distance that the sensor is able to detect. If we do this, we actually get a G, which I think it's pretty cool. You can even tune the theremin however you want, which I would expect. Okay, so we got our Arduino here very professionally hooked up to the sensor and to the computer. So if we start the program right now, we should see that the console will start. It will connect to the Arduino. It will tell me to press any key, okay? And we're going to start the theremin right now. Now, if it detects that the distance is more than about 100, I think, then the amplitude of the wave gets reduced to 0. So that basically means that we will turn all the volume down. Why? Because I don't want high-pitched sounds, and I think it's really cool that we can control that. So I'm going to press a key to start the theremin. And that's it. It automatically is telling us the frequency and the distance. The frequency right now would be 880 hertz, which I don't know what musical note that is, but I'm pretty sure it's one of them. And so now I'm going to put my hand over this and... Okay, yeah, just like that, you should start hearing a little bit of a sound right there. That's 391 hertz. I think that's a G. This is the lowest this can detect. So if we go up a little bit, if we go up a little bit, we should be detecting, we should be reading G sharp, A flat. So a little bit. That's a G sharp. I'm gonna go up to an A. Okay, that's an A. You see, 440 hertz. That's a G. An A. I'm sorry. I'm gonna go to A sharp. Oh, sorry. It's a little bit sensitive. That's A sharp. Okay. Let's go to a B. Okay, that's a B. Let's try to go for a C. That's a C. Hey, C sharp, the language in which we coded this. Haha. Let's try to get a D. D is actually really hard. Okay, that's a D. No, that's a D right there. Come on. It's kind of hard to position your hand in the correct way. But again, the original theremin is already really fucking hard. I know this is harder, but hey, wasn't that a fun ride, am I right? So I originally planned on doing a cover of Memory by Alan Page from the musical Cats. Not the movie. The movie was shit. The musical. But turns out that thing is really hard to play. So I might do a cover. I need a little bit more practice. I need a lot of practice, to be honest. I might do a cover in a later video. Who knows? But yeah, that's the video. Let me know what you thought of it. And if you want to recreate this project, you can go to the GitHub repository that I'm going to link in the description. And you'll have all the source code right there. So yeah, that's that. Don't forget to sexually assault the like button and beat the crap out of the subscribe button until it starts begging for mercy. That's it for me for now, and thanks for watching.